I apologize. Great, got it. Great, my introduction would be recorded. But
No,
hi,
I
everyone.
didn't.
Yeah, welcome to NJ's guest talk. So NJ and I have known each other for how long now? About 10 years?
I guess so, yeah.
So NJ joined the Sensible City Lab as a researcher around that time while I was doing my PhD. He eventually got into Harvard GSD and for the master's in urban planning, was it?
Technology, master technology.
Yeah. Okay. But I recall around that time you started working a lot with GIS, with geographic data, a lot of mapping stuff. But actually NJ's background is more in architecture, generative architecture, data visualization, rendering. So he's like a real wizard at this kind of stuff, especially making things look great. And then I think you spent some time at Berkeley as well, also studying urban planning, GIS. And we're kind of back and forth between the US and Korea, but now you're kind of landed at Esri, Esri being the largest GIS company in the world. So I will leave it at that. NJ, you do a really good job of kind of presenting your own work. But yeah, it's a pleasure to have you. Why don't you jump in? As a quick reminder to everyone, we are recording this session. So if you don't want your face to be in the recording, don't turn on your camera. But I do encourage you to have questions towards the end. All right, NJ, it's all on you.
Okay, thank you for having me here. I'm excited to share several projects which is related to not only GIS, but also design things. So yeah, we have a limited time, so I'm gonna share my screen. So you guys can see my screen, right?
Yes.
Okay, great. Yeah, today's topic is about, like, in general, data and design. As David mentioned my background, my name is Namju Lee. You guys can call me NJ because it's easy to memorize, right? And also I'm work as a software engineer at Esri, developing mapping and drawing or 2D or 3D graphics. And also personally, I'm interested in computation design, which is about intersecting between designing based on the computer principle and developing some pipeline or solution for design, I think. Okay. So today's topic is I'm going to focus on spatial information, which is actually GIS, and also discretization, which means how we dealing with the information on the spatial way, right? And then the last topic is design methodology, which is actually decision-making process for your design process, whatever process for using GIS data. So to begin with, I'm gonna have a question to you guys. So I think the stone, glass, plastic and iron, concrete, which is the most important material, right? So this kind of material is actually changing our life, right? This is because the material has its own properties, but also the technology, being used to facilitating this kind of material is also evolved. So the precision of the tool is getting increased so that we can, process this kind of material to change our life, yeah, or our city. So when you read this keyword, what comes to your mind? Like, smart city, AI, machine learning, parallel computing, edge computing, things like that. So I think when I see this kind of keyword, we easily, think about fourth industrial revolution, right? But I guess the essence of the fourth industrial revolution is actually data, because this is all about how we collect data, how we process the data, right? And how we extract the insight from data. The lastly, how we apply the insight from data to our daily life, right? So in that context, the data has become most important sort of material for modern society on top of this kind of physical material. So in data at design, there's a lot of different types of the level, perspective over sections. But today we are going to focus on GIS perspective. So this is the Wikipedia definition, like, it's very common things, but I want to emphasize, like, what is the GIS? GIS to capture and analyze spatial and geographical information. This is, I think, the essence for us, because we want to capture, basically, we want to freeze or capture and the events or phenomena, right, as a numeric set of information, and we wanted to analyze in order to extract insight from the data, right? So I guess you guys already learned about what types of GIS data by David, right? The raster data and vector data, which is essence of, I mean, the basic category of looking at the GIS data. The first of all is raster data is basically, you guys can think about like image, right? It has like a two-dimensional matrix. So individual pixel has their own value, such as RGBA or hue saturation value or grayscale value with opacity, things like that. So color is not just like a pixel. It has actually a lot of meaning, right? So, you know what, actually I compressed this presentation as a PDF file. So I'm gonna give you so you guys can click to get more information. But I'm just, because lack of time, I'm gonna quickly, gently touch individual projects. So in that project, if you just very simple, but the behind the scene, actually what I'm trying to do is create a process to extract the data or information by dealing with the pixel size. So also you guys familiar with the remote sensing, right? Remote sensing is basically also to deal with the pixel, how we dealing with pixel basically. And also the color has a different kind of space, like RGB or hue saturation value or LAD space. So individual space, their own unique properties. And based on these properties, we can also apply some KNN, like this is very common, widely used for machine learning, because these are how we deal with color, how we kind of apply the process, to understand what the color meaning on the GIS context. And the second project, which is actually I proposed for our kind of hackathon and ASRI. So I utilized the GAN network, which is one of the popular machine learning network these days. So for the application is that we have a drawing to here, so people can draw like some line or area based on the color code. In individual color code have their own meaning. Yeah, it's like highway, freeway, park, font or free, something like that. And then I actually trained the network based on the data from about LA, London, Seoul, Manhattan. So when you draw your own like a basically abstract city, and then it gives us some basically sketch on top of the basic kind of guideline in order to generate this kind of Google Map-like map. So these are also one types of kind of approach using the conventional, the beyond the conventional GIS application, I guess. This is the demo video, so can skip it because I'm gonna share the link with you guys. This is another example. I submit this project for the Seoul Biennale International Studio with Dong-Se Kim, who is a professor in NIIT. He's also specialized in urban design. So what we wanted to try is to compare between High Line in Manhattan and the Solo in Seoul, because the principle or ideas behind the scenes are very similar to each other. It's basically convert the old, like revitalizing the old structure. And we actually capture like 3 months data from the Instagram and Twitter. So there are two types of information, right? One is the image data, right? We can consider as a raster data. And the other one is text data, which has a lot of noise, but also we can convert this text data as a numeric data so that we are able to process and then find some relationship between the picture and text. Also, we can find the correlation between the highline and the solo within exact time period. So also this is the kind of tool to understand what the happening behind the scene. Even if you design something based on your intention, the result is gonna be a little bit different. So in this case, we need to analyze why it's different, how different, right? What is the key value to maximize the difference, for example. So these are kind of example. This is video. I'm gonna jump it. And also, this is an example like how we utilize two different types of GIS data. One is the image data, as you can see here on the right bottom. So I pass all the Boston area based on pixel level for the Google 360-degree view. And then using the machine learning, I can basically convert image data into numeric data by semantic segmentation. And also we have a lot of numeric conventional data. It's like population and energy usage and things like that. This is also the same approach. But the most important keyword behind the scene of this project is to figure it out how the kind of the visual perception has a relationship with the economic data. So we wanted to try to understand how Boston, is characterized based on this relationship. This is a video. I can skip. I'm sorry. So we have left time. And this is the project I did in Media Lab in the Changing Places Lab with Professor Kent Larson. What I did is actually there's a very precise instruction on the kind of the website, and also I submit this one to the paper, so you guys can have a more better idea if you guys are interested in that project. This is the project. I'm trying to understand the city based on the third place lens. So I used some Google third place and other the map, digital map, in order to parse the third place and the location and the name of the place. And then I can categorize multiple place into 6 categories. You guys know what is the third place, right? The first place is home, right? The second place is workplace. The third place is all place between home and work. So coffee shop become, third place, and bank or gym can be considered as a third place. So third place is actually very important to understand the characteristic of the city, right? So I mean, there's a lot of GIS data. Also, we can parse the third place by the shapefile or whatever data provided by government or local government or national government, whatever things. So anyhow, so we have a data, right? The data is just like kind of raw mineral. So we need to process the mineral in order to make some product or get some insight from this raw mineral, right? So in this case, what I try to do is using the network analysis, I'm just analyzing based on the distance. Also, the distance can be considered for the human scale, right? Like a 5-minute walkable distance or 10-minute walkable distance. So based on this distance, we can actually compute the energy consumption and time consumption. With the vehicle or by work, or there's a lot of a metric we can analyze this other place. So, and the interesting diagram on the right and the bottom is in this case, basically I convert vector data. Vector means in a number, right? So numeric data to the raster data. So in this case, I maybe at the end of the slide, I'm gonna introduce the methodology that I utilized for these projects. But basically, we have a continuous data or discretized data. So basically, every data in compute is discretized data, right? But there's some perception, right? Sorry. The resolution basically. So for example, we have here right? We have some crime is happening here. So this event, does it affect only that area? I would like to say no. This event is gonna affect their area, right? Like gradually, right? So in this case, we need to interpolate the data between place to neighbor place, so that we basically encode all numeric data in this kind of two-dimensional space, and we try to interpolate the relationship between data and data, which is a very interesting topic, to be honest. So anyhow, this kind of technology is applied to that project. So this is the kind of the example or demonstrate video. This is also extension of the network analysis, which is a quite professional application. So Dr. Jong-Yun Woo and me, we built this kind of very quick analysis of the network. This is actually this plugin you can download from the for Rhino if you guys utilize the Grasshopper, for example. So conventionally, the network analysis is a very long history. It has a long history and very robust, like a kind of a framework to analyze the network. So in this case, we have the centrality and accessibility analysis. There's some mathematical equation behind the scene. But what we wanted to try to do is there's two things like a centrality analysis and accessibility analysis. The individual analysis has their subcategory to kind of the analyzing and give us some feedback. And based on this feedback, we can evaluate the network and how we improve the network, how we degrade the network. For example, like in order to analyze the network, so the distance space is a kind of a primary data or primary how can I say factor for understanding the network. But at the same time, even if the distance is so big, if there's for example, if the street has a culture where a lot of fun things happening, where we have a grocery shop or some other shopping mall is located on that street, so that the street is actually gonna be activated because of the characteristic of the street. It's not about only distance. So we actually apply this kind of the range or parameter on top of these conventional researches. So these are kind of network analysis. And also at the same time, under geographical scale, we have the other types of data, right? So previously, we deal with the data, like for example, like third place or energy consumption. This kind of data is actually, collected by some government or some agency. So my understanding, if I say wrong, please correct me, David. My understanding of the data is every data has a bias based on the constitution to collect the data, right? Because they have an intention, right? And on top of this, we have the other frame, which is kind of simulation, which is kind of, there's no life factor, right? Because this is just pure data, right? But, in order to capture the national kind of environmental activities, almost impossible because there's insanely, robust data. Even we couldn't, mimic that things because it's kind of a complex system, right? But for that kind of the fluid dynamic system, we have a very abstract, complex environment into particular parameters, and then we can actually simulate within particular tolerance, right? So in that context, we can, while you're designing, we are able to get some feedback based on the insight from the model that we design based on this kind of environmental factor. This is also very good and useful to understand the data that you collect. Also, I don't know, I mean, if you have more experience to dealing with data, there's a lot of pre-process for the data. For example, like if you have the one data set, we have no idea what's happening in that data set. And you guys have some hypothesis, right? And then you can pick the other data and then try to relationship between two data, right? Or we can add more data. We can maybe remove one matrix or data set. And then within this 3 data, for example, you can process the other data in order to do other design making process or understand the other data set. It's like a very, how can I say, it's not just like tracing something, it's basically mapping. It's basically based on your hypothesis, your story, you need to sometimes prove or sometimes mining some insight. This is kind of entire process has become important, right? So in that context, we have the other parameter or data, geographical scale data by understanding our environment. This is the other kind of particle simulation things. And also, this is the other example. It's a little bit different than GIS, but as I said before, like we have a complex system. I mean, there's two things, I guess, it's harder to dealing with the complex system. One thing is how we parameterize our actual environment into particular variable, right? This is not easy. And the other thing is that how we set up the relationship between object and object, right? Because once we know how to parameterize, how to get the relationship or the interdependence between the data and data, then it becomes easy, I guess. So in this project, what I'm trying to do is we have a basic data, like we have a cloud basically release the water, right? And then tree can consume the water at a particular level within the tolerance, obviously. And then we basically apply some relationship or tweak the relationship to mimic the complex system. The reason I'm presenting this project is just don't take a look at the data as it is. Yeah, obviously we need to understand what is the data as it is, but at the same time, we need to pre-process the data in order to prove your hypothesis or your usage or your decision-making process. So what I'm saying is the data pre-processing is not just apply in a traditional statistical equation, but also you can make some you guys own equation to process the data.
Hi, NJ, so we're at about a little over 20 minutes now.
Oh, okay.
So we are running a little late. Is there anything from your work at Esri that you'd like to show?
Oh, yeah, okay.
Yeah.
So give me 3 minutes.
Yeah, sure.
Okay, good. So yeah, these are projects that I did is inventing some clustering things. So I saw I mean, there are several process. I mean, the conventional methodology to improve and the implement clustering points. So, but I invented some clustering algorithm because we don't want ruin the organization or constitution of the cluster by interacting with your mouse. These are kind of the things that you got. There's a link for the Medium, so you guys can go see the steps. And this is mapping. Mapping is important. Because mapping is, I think, is one of the beautiful way to understand the data. Because the GIS data is basically has a location, which is fantastic, to be honest. So based on the location, we actually see the other pattern or some meaningful gesture of the data. So this is the things actually something I built in Esri. And also, luckily, we have this kind of video. I actually compress my work. Some is like something hidden things, but you guys can see it because as an educational purpose, yeah, I can share it. And this is a methodology. So in order to deal with methodology, as I said for our previous presentation, I utilized graph and pixel and 3-dimensional pixelized DOM as a voxel. So based on this kind of data structure, I embedded the data, and then once we have a data, we need a system, right, to how to cook the process, the data. There is like several philosophy, the agent-based or rule-based or generative process, for example. We can apply similar principles to process the data. And then once we project data into geographical environment, it becomes geometrical problem. So we are architectural designers, so you guys are familiar with the geometry problem, right? So, and then this is my last material. So I have not only the video or some description of my previous project, but also I have some Medium page and CodePen that you guys can learn something about the
NJ.
things. Thank you.
NJ, yeah, can you take us back to that slide for your San Francisco data visualization?
Yep.
I think that's like for the class, at least, maybe the most relevant because, we're trying to figure out good ways of visualizing GIS data, spatial data. So
yep.
Can we look at this real quick?
Yeah. So I can have several comments on it while playing the video. So, San Francisco is a quite famous city these days, but previously the city was vitalized based on the World War II. And also nowadays San Francisco is a kind of the city for the IT tech or high tech, like business, things like that, and also big companies located in San Jose or San Francisco or Bay Area, right? So in order to understand this particular San Francisco area, so I mapped like GIS information in the more larger scale, on an entire Bay Area. So based on the property of the land, I'm trying to understand how the city was evolved, and the existing building and existing research has something to do with this kind of the land research. For example, like the Bay Area, there's a lot of how can I say, the protected area, and some places is people cannot go to because there's some mud and sea tide, And also I apply the basic GIS data on top of the Bay Area, and then I focus and narrow down the San Francisco area. And particularly I'm trying to focus on the free stuff, because at that time, the San Francisco was the top city, not only for the tourists, but also like homeless people. Because the homeless people is actually relying on the free stuffs, right? So based on the free stuff, I'm trying to indirectly track how homeless people, interact and take advantage of the city shape. And as you can see here, the Market Street is one of the important and famous street in the San Francisco. So throughout the Market Streets, there's a lot of free things happening. So I mean, this is a very quick demo video. So yeah, there's a website, and then you guys can see some description here. Okay, let me.
Yeah, and NJ, I wanted to ask a bit about like some of the decisions you made when you were visualizing that data. So first off, what are you showing in that image of San Francisco?
So in that image, I just basically trace something. Trace meaning, I just dump existing information on top of the.
Right. So what were those layers? Like what were we looking at?
The layers are the free stuffs. Free.
So
internet, free water.
Mm-hmm. So like social infrastructure for
exactly
people.
Yeah.
So free access to, you said,
internet,
water, shelter,
exactly.
Internet.
Mm-hmm.
Okay, so those are like, that's like the distribution of infrastructure. That was a point data set, like you had addresses.
There are multiple parameters. So basically, I utilize the color computation, because we apply 3 RGB color become white, right? So individual color set can represent, like red is become free internet, for example. But we couldn't see in this presentation from here, but the strategy behind the scene is like that. So color apply and then see the difference.
Right. And then what are these circles then?
The circle size is, as I mentioned before, we have a free food here, for example. This point is not affect only that particular area and particular point. It basically affects their area gradually. Mm-hmm. So I'm trying to play with the radius based on the walkable place, walkable distance, basically.
Mm-hmm. Mm-hmm. But you're drawing buffers around all of those point sources of
exactly.
support, to the homeless population.
Yeah, and then if the point is lying on the very close distance, it becomes like a one giant area, so which is also important fact rather
Right.
than one point.
Yeah. So yesterday the students have been working with buffers and drawing buffers around
cool.
point features. So
Mhm.
you have that option of when you have
Exactly.
multiple buffers that overlap each other.
Yeah.
Because points can be clustered.
Exactly.
Do you dissolve them and just
Mhm.
make them one single geometry, or do you let them
Exactly.
overlap?
Mhm.
And in this case, you're using opacity to
the density
to
of
kind of,
the
to show like that there's more concentration of these resources
Exactly.
here rather than elsewhere in the city. Okay. Did you end up like showing, so this is where the resources are. Was there a data set that showed the actual like homeless population, like where they are located, where the camps are, where there are like potentially like complaints from citizens or arrests or things like that?
Unfortunately, there is no particular data which is directly related to the homeless places, but I lived there like around 1 year, so we know we know what kind of the places people don't want to go to because of the homeless. So yeah, this is the we have no data for that one. So that's why we try to do. I mean, actually, in the website there's the book that we reference, which is about how homeless people like activity during the day. So there's a very particular pattern. So we actually try to kind of like how can I say? There's no particular data to prove this behavior directly. So that's why we make a model which narrative the concept by indirectly based on the data that we can actually understand and then attract for the homeless people. It's pretty tough, but it was really fun.
Yeah. So the database is really focusing on the infrastructure, the social infrastructure that potentially that can support this population. We don't really know where the population is or their movements, but that would be what we would want to eventually want to correlate against this.
Exactly. Yeah.
Okay. Okay. Well, thank you, NJ. We are well over our time, but a lot of really cool stuff, obviously, well beyond GIS. But I would encourage everyone to take a look. I think NJ, you're going to send me your slides or some links.
Right now, okay. I will send you the materials. So David.
Yeah. So I'll forward it to the class. If anybody has any questions about anything you see in there, I know this was a quick presentation. So if you wanted to like ask some follow-up questions, if you're interested in any of these techniques, in particular, NJ, you showed us some Rhino plugins or Grasshopper plugins that are essentially acting like a GIS. Like so far in the class, we've been only working with QGIS, but students should feel comfortable like using other tools, especially if you're comfortable with Rhino and Grasshopper, and you want to do network analysis in there. That's totally fine. The tools are out there. NJ has written a few of them, so we can definitely connect you. Does anybody have any questions for NJ before we break? Okay. Yeah, again, feel free to reach out. You can, I'll connect you to him if you had anything you wanted to ask directly. And thank you, NJ.
Thank you so much for having me here. And then for those who missed this presentation, I just one guy is how to make this presentation. So anyhow, so I will upload this video. So if you guys interested or missing something, and then visit the video and then see and keep studying. Yeah.
Okay, great.
Thank you.
Thanks. Class, I will send out a link to the next meet. Actually, no, I'm going to contact the teams individually. So from